Okay, let's do work a couple of quadratic equations, solve a couple of quadratic equations using the quadratic formula. And I have three that I'm going to do here. And so we're just going to first of all make sure that we know the quadratic formula itself, which is a way to find x when we have a quadratic equation, and it looks like this: negative b plus or minus the square root of b squared minus 4ac all over 2a. We're going to use that to find x. You notice it says x equals. That allows me to find the x value when, let's say, I can't factor, or I don't want to complete the square, or some other reason. I can use the quadratic always. It always solves the problem for me. So it does tell us to use it. So my a in this case is the coefficient for the x squared, so that's a 1. My b is 7, and my c is 5. So here I go, putting it in the formula. I get negative 7 plus or minus the square root of, by the way, this is all x equals, so I have 7 squared minus 4 a c all over 2a. And we're just going to simplify. We have negative 7 plus or minus. You should not need a graphing calculator for this process, so get in the habit of finding these numbers without it. Okay, so let me move this down a little bit. I can finish up. Okay, so I have x equals negative 7 plus or minus the square root of what, 29 over 2. Now, I'm looking at 29 and I'm wanting to see, is there any kind of perfect square that would be hidden inside of the 29? If so, I need to simplify it. Well, on further inspection, no, I can't see anything that's going to be in there that's a perfect square. In fact, 29 is prime. So that's my answer. Now, a lot of books will tell you to do this. Go ahead and split up the denominator and go ahead and write it this way, right? Split up the denominator, because later on when we have imaginary roots or answers, then we're going to need to put it in a plus bi form, and so this is a good habit to get into, to split the denominator up and give each one their own 2 in this case. Let's take a look at the next example. Okay, so those are our two answers. Let's take a look at this blue one here. A in this case is 1, B is negative 5, and C is 12. And here we go. X equals, now notice that the B is negative, but the formula owns a negative, negative B plus or minus, so I'm making sure that I put the negative 5 in there after the negative as well. Alright, so I have negative 5, and this is very important that you put that in parentheses. You realize that negative 5 squared is negative 25, but negative 5, which is what we're supposed to do, which is put it in parentheses to substitute, is positive 25. So that's really important that you know the difference. So you need to put, when you're substituting, you need to use parentheses. Okay, so minus 4ac all over 2a. Okay, here we go. X equals, that's going to be a positive 5 plus or minus. Okay, so that's 25 minus, and that's going to be what, 48? Alright, so now immediately I'm looking at this going, I'm going to have an imaginary answer. You can see that as well, because when I have 25 take away 48, I'm going to end up with a negative 23 under the radical. And we know that the square root of a negative is going to involve an imaginary answer. So let's go ahead and do this. Let's go ahead and say 5 plus or minus. Now, the radical 23 is negative 23 is the same as the radical negative 1 times the radical 23. Well, we know that this is the same as the letter I. So this is going to be I square roots of 23. Okay, that's what that really is. So I'm going to replace that with I square roots of 23. Now, if 23 would reduce or simplify, I would do that, but it doesn't. It's prime as well, like the other one. Alright, so I'm going to come over here. I'm out of room down there. Now, what I'm going to do is go ahead and give myself a separate denominator for each one, right? I'm going to show you how they typically want this to be written. We really usually want the imaginary answers in this form, a plus bi, which means that the I you want to put on the ground next to the second term. And so anyway, probably the book or whatever your book you're working with is probably going to ask you to do it this way. So we separate the denominator and we make sure we place the I down there on the ground, down there on the baseline. Okay, so those are two imaginary answers. All right, now let's look at this last one. And here's the thing, this one is not in this form, ax squared plus bx plus c. It's not in the standard quadratic form, and so what we want to do is get it into the right form, because otherwise we can't look for all of our positions a, b, and c here, right? So let's go ahead and move the 6x back over to the left, because it needs to be in the right form so that we can pull off the numbers properly. So let's see if this is what we have now. We have 9x squared minus 6x plus 1. Now I know that a is 9, I know that b is negative 6, and I know that c is 1. Now I'm ready to put it in the quadratic. Here we go. That's going to be negative 6 plus or minus the square root of 2 times 9. Okay, that's going to be b squared, negative 6 squared minus 4ac, and here we go. That's going to be a 6 plus or minus. That's over 18. That's going to be a 36 minus, look at there, a 36. I have 36 minus 36 is 0. What is the square root of 0? Well, the square root of 0 is 0. So I have 6 plus or minus 0 over 18. Now in this case, my answer isn't imaginary, it's not even irrational. I don't even have two answers, right? Because plus or minus 0 is just this. And so I'm going to always reduce my fraction. And so my answer is 1/3. So this 1/3 is my answer. And a lot of times you'll see it in a set like that. One answer only. Okay? All right, I hope this helped. And thanks for watching.